Hey, and today we're going to talk about moments of a force. So, what is the moment of a force? Well, the moment of a force refers to the chilling effect of a force around a pivot or point, and the formula for this is m equals force by distance. So, m is the moment of a force, and its units are Newton meters, Nm. F is of course just the force, and its units are newtons, and d is the distance of the force to the pivot, which is meters. Now let's look at this clearer in a diagram. So we have our pivot here. Let's call this point P, and let's say we have a force acting here. We call it F, and we'll give it a value of 20 newtons. And let's make the distance to be 2 meters. So what is the moment of this force? Well, the moment of this force is the moment is equal to the force by the distance, which is equal to 20 by 2, which is equal to 40 Newton meters. It's as simple as that. Now let's look at clockwise and counterclockwise moments. So in this case, which direction will our movement be? Well, since our force acts upwards, it will cause our pivot to rotate anti-clockwise or in this direction. However, if our force acted downwards, let's say over here, it would cause our pivot to rotate in a clockwise direction. So this way. Now let's look at the principle of moments. So for an object to be in equilibrium, the sum of clockwise moments about a point must be equal to the sum of counterclockwise moments. So what does that mean? Well, let's just erase this. Let's say we have a force here of 20 newtons at a distance of 3 meters. Then for this object to be in equilibrium, we need to have a force on the exact opposite side here of same 20 newtons and at a distance of 3 meters from the pivot. Now on the right side, this force acts counterclockwise, and on the left side, this force acts in a clockwise direction. Therefore, the clockwise moments and the counterclockwise moments are equal. Therefore, it is in equilibrium. And that's for the introduction to moments of a force. I hope it was informative, and thanks for watching.